Hello and welcome to Doc Onco's Physics. Keith Onco here. Today what we're going to be taking a look at is yet another problem in kinematics in one dimension in the x direction. In today's problem what we have is we have a train traveling along a straight section of track at 30 meters per second when the engineer applies the brakes. The application of the brakes causes the train to accelerate at -1 meters per second, or -1 meters per second squared, while the train is still in motion. And part A says, how long will it take for the train to come to a complete stop? So let's see what information we have here. Well, 30 meters per second. So a train is traveling along a straight section of track at 30 meters per second. So the 30 meters per second is going to be my initial velocity. So I'm going to add that to my table over here. When the engineer applies the brakes, the application of the brakes causes the train to accelerate at -1 meters per second squared. So my acceleration, or deceleration in this case, is going to be -1 meters per second squared. Okay. Now, how long will it take for the train to come to a complete stop? So what else do we know? Well, we're not explicitly told that the final velocity is 0, but it says that if it's going to come to a complete stop, we want to know how long it's going to take. So the final velocity is going to be 0 meters per second in this case. All right? And what we're looking for is time, because this is how long. How long will it take? So we're looking to find the time initially. Okay, so let's see what we've got. Well, we have initial velocity, final velocity, and acceleration. We'd like to find time. Well, the second equation here looks very well suited for that. We have the final velocity, we have the initial velocity, and we have the acceleration. Seems like it's just a matter of plugging the variables in to get the right value. So let's see what we got. So time. Final velocity is 0 minus the initial equals the initial velocity, which is 30 meters per second, plus a times t. Well, a is -1 meters per second squared, so it's a pretty slow acceleration. We've got the 1 there, -1 meters per second squared times time. Well, what I'm going to do is I'm going to move this to the other side of the equation, and I'm going to get -30 meters per second is equal to -1 meters per second squared times time. All right. And I divide each side by -1, and my time turns out to be 30 seconds. All right, so I hope that no one's in a big rush for this train to come to a stop. So time is going to be 30 seconds. Now we'd like to know how far the train will have traveled while decelerating. Well, how far is displacement, delta x, which is x final minus x initial, right? As is usually the case, I'm going to take x initial to be 0, right, because that's my right in these physics problems. So if we look at the problems here, let's see, which equation would help us? Well, I'm looking for how far the train went. So here's an obvious equation, x final equals x initial plus v0t. Well, we have v0, right? We know that, v initial. And we have the acceleration. Right? So we have all the variables, and we now have time. So we could use the third equation. Could we also use the fourth equation? Well, we have the final velocity, we have the initial velocity, we have the acceleration. We could use that as well. Either one of these would work. Okay? I'm going to use the third equation, and let's see what we get for an answer. So x final is going to equal 0, which is x initial, plus v0 times t. Well, v0 is 30 meters per second times t, which is, let's see, 30 seconds, plus a half at squared. So 0.5 times -1 meters per second squared times 30 seconds squared. All right, so when we do this math here, what we end up with is 30 times 30 on this side is 900 meters over here. Okay, the seconds cancel out. Plus, well, let's see, 30 times 30 over here is 900. 900 times -1 is -900 times a half is negative 450, and the units turn out to be meters over here as well. So what's my answer? Well, it's going to be 900 minus 450. It will have traveled 450 meters during the time when it was slowing down, and then finally comes to a stop. So I hope that helps. We'll see you next time.